September 19th, 1942, Schweinfurt, Bavaria. Oberingenieur Klaus Hartmann pressed his forehead against the cold window of the Kugelfischer ball-bearing factory, watching the morning shift arrive on bicycles and on foot. His design specifications for the new production line lay rejected on his desk behind him. Too ambitious, his supervisor had written in red ink across the top page. The Reich cannot spare these resources for experimental methods. Outside, workers filed into Germany's most critical industrial facility, the plant that manufactured 67% of the ball bearings that kept every tank, aircraft, and ship in the Wehrmacht operational. Each bearing required 4 hours and 20 minutes of skilled labor, hand-fitted and individually tested. At current production rates, Germany manufactured 12,000 precision bearings daily, barely enough to replace combat losses. Hartmann had calculated that with automated assembly methods, the same workforce could produce 50,000. But automation required machine tools Germany didn't possess, electrical capacity the Reich couldn't generate, and precision standards the traditional craftsman guilds refused to accept. The mathematics of industrial defeat were already visible to anyone who cared to calculate them. America's automotive industry, he had read in a confiscated report, produced more vehicles in 3 months than Germany's entire industrial capacity managed in a year. What Hartmann couldn't know was that within 16 months, he would stand inside an American factory, watching assembly lines produce complexity at speeds he had dismissed as physically impossible. The cognitive demolition of his engineering assumptions would be so complete that he would spend the rest of his life trying to explain to fellow Germans what he had witnessed. The explanation would always sound like fantasy. In September 1942, Germany stood at the peak of its territorial expansion. From the Atlantic coast of France to the outskirts of Stalingrad, from Norway's Arctic Circle to North Africa's Mediterranean shore, the Wehrmacht occupied or controlled over 2 million square miles. This empire required industrial support on a scale Germany had never achieved. The Nazi economy operated under what historians would later call the production principle, a system that prioritized quality over quantity, craftsmanship over mass production. Each military item was built to exacting standards by skilled workers using methods unchanged since the previous war. A panzer tank required 1,200 man-hours of labor and took 6 weeks from raw steel to battlefield delivery. Each one was essentially custom-built, with measurements taken and parts hand-fitted during assembly. The Mauser rifle, backbone of German infantry, needed 8 hours of skilled gunsmith work per unit. Even artillery shells were manufactured with tolerances so tight that many required individual inspection and adjustment. This obsession with precision engineering was deeply embedded in German industrial culture. The craftsman guilds, dating back to medieval times, maintained strict control over production methods. A master craftsman's authority was nearly absolute. Apprentices spent years learning traditional techniques before being certified. Innovation that bypassed guild approval faced institutional resistance. Albert Speer, appointed Minister of Armaments in February 1942, had begun recognizing the fundamental problem. German industry was producing weapons of exceptional quality in quantities utterly inadequate for modern warfare. His initial reports to Hitler laid out the mathematics with brutal clarity. Germany produced 2,250 aircraft monthly. Intelligence estimates suggested America would reach 8,000 monthly by year's end. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. German tank production averaged 310 units monthly. The Soviet Union, despite losing vast industrial regions, was producing 1,200. Even Britain, with a smaller industrial base than Germany, exceeded German output in most categories. The disparity wasn't about resources alone. Germany controlled the industrial capacity of Czechoslovakia, France, Belgium, and Poland. The Reich had access to Swedish iron ore, Romanian oil, and Ukrainian grain. What Germany lacked was not materials, but method. The industrial philosophy that prioritized individual craftsmanship couldn't scale to meet modern war's demands. Klaus Hartmann represented a generation of German engineers who understood this problem intellectually but lacked the institutional power to solve it. Born in 1903 in Nuremberg, he had studied mechanical engineering at the Technical University of Munich, graduating in 1926. His doctoral thesis on precision bearing manufacture had earned him a position at Kugelfischer, Germany's premier bearing manufacturer. By 1938, at age 35, he was chief production engineer, responsible for maintaining output at the Schweinfurt facility. Hartmann had travelled to America in 1937 as part of a German industrial delegation studying automotive manufacturing. The visit had been arranged under a technical exchange program, one of many such programs that allowed German engineers to tour American factories before the war. He had spent 2 weeks observing production methods at Ford's River Rouge plant, General Motors facilities in Detroit, and several smaller manufacturers. What he witnessed had challenged every assumption about manufacturing he had learned in Germany. At River Rouge, he watched raw materials enter one end of the facility and finished automobiles exit the other in a continuous flow that never stopped. The scale was incomprehensible. 100,000 workers, 27 kilometers of conveyor belts. The facility consumed more electricity than the entire city of Berlin. But it was the philosophy that shocked him most. Where German craftsmen hand-fitted components until they achieved perfect tolerance, American workers simply bolted together parts that were manufactured to such precise specifications they required no adjustment. An engine block that would take a German mechanic 2 days to assemble was put together by American line workers in 27 minutes. The American foreman who guided the German delegation explained the principle with casual confidence. "We don't have master craftsmen," he had said. "We have interchangeable workers assembling interchangeable parts. Any worker can do any job with 30 minutes of training because the system doesn't depend on individual skill. It depends on engineering precision in the parts themselves." Hartmann had returned to Germany with detailed notes and revolutionary ideas. He proposed redesigning Kugelfischer's production around American principles, manufacturing components to tolerances so precise they would be truly interchangeable, eliminating hand-fitting entirely. His proposals were rejected by the guild masters who controlled production standards. American methods, they argued, sacrificed quality for speed, produced inferior products, and eliminated the skilled craftsmanship that made German engineering superior. The outbreak of war in September 1939 temporarily silenced such debates. Germany's initial victories seemed to validate existing methods. Poland fell in 26 days, France in 6 weeks, Yugoslavia in 11 days. The Blitzkrieg succeeded through tactical innovation and operational surprise, not industrial superiority. German weapons, built with traditional craftsmanship, performed superbly in these short, decisive campaigns. But as the war expanded into a multi-front conflict requiring sustained industrial output, cracks appeared in the German system. Aircraft production couldn't replace combat losses. Tank factories couldn't meet expanding army requirements. Ammunition consumption exceeded production capacity. U-boat construction fell behind schedule despite desperate need. By 1942, the limitations of craftsman-based production were becoming catastrophic. Hartmann's rejected proposal sat in the archives while Germany's industrial capacity strained toward collapse. The American industrial awakening that Hartmann had witnessed in 1937 had accelerated dramatically after Pearl Harbor. Roosevelt's declaration of becoming the arsenal of democracy translated into production targets that seemed fantastical even to American industrialists. The numbers were staggering by any measure: 60,000 aircraft in 1942, 125,000 in 1943, 45,000 tanks in 1942, more than Germany would produce in the entire war, hundreds of thousands of trucks, millions of rifles, billions of rounds of ammunition. But the transformation went deeper than numbers. American industry was being redesigned from first principles to maximize production speed. The revolution occurring in American factories would have seemed like science fiction to German engineers raised in the craftsman tradition. At Willow Run, Ford's bomber plant outside Detroit, B-24 Liberator bombers rolled off the assembly line every 63 minutes at peak production. Each aircraft required 1.5 million parts from over 1,500 subcontractors. The assembly line stretched over 1 kilometer inside a single building covering 2.5 million square feet. Henry Kaiser's shipyards were building Liberty ships, 10,000-ton cargo vessels, in an average of 42 days. The record was 4 days, 15 hours, 29 minutes from keel laying to launch. Traditional shipbuilding required 6 months to a year. Kaiser achieved this through prefabrication and modular assembly, methods that would have been dismissed as impossible by traditional shipwrights. The Chrysler Tank Arsenal, producing Sherman tanks using automobile production techniques, manufactured 1 tank every 55 minutes. The facility could build more tanks in a month than Germany's entire industry produced in 3. These achievements weren't just about working harder or longer hours. They represented a fundamental philosophical difference in how production was conceptualized. Where German engineers started with craftsmanship and tried to add efficiency, American engineers started with the production system and designed everything, including the product itself, to maximize manufacturability. This inversion of priorities was the invisible revolution that German engineers wouldn't fully comprehend until they saw it directly. The principle was simple but profound. Instead of building each product individually with skilled craftsmen adapting to variations, American methods eliminated variation at the source. Every part was manufactured to tolerances so precise that any part could replace any other part without adjustment. This interchangeability meant that unskilled workers could perform complex assembly by simply following procedures. The economic implications were enormous. A skilled German craftsman required years of training and commanded high wages. An American line worker could be trained in days and replaced easily if lost to military service. Germany's reliance on skilled labor became a strategic vulnerability as experienced workers were drafted into military service. America's system-dependent production could scale infinitely by training new workers. The electrical power requirements alone revealed the scale difference. A typical German industrial facility operated on electrical capacity measured in hundreds of kilowatts. American factories consumed megawatts. River Rouge used enough electricity to power a city of 500,000 people. This power enabled automation impossible in German facilities operating under chronic electrical shortages. Machine tools in American factories operated continuously, powered by electrical motors that never tired. Conveyor systems moved materials without human effort. Electric welding replaced riveting in shipyards, reducing hull assembly time from months to weeks. Automated painting systems in aircraft factories completed in hours what German craftsmen required days to finish. The disparity in electrical infrastructure reflected deeper economic differences. America's rural electrification program, begun in the 1930s, had brought power to 90% of American farms by 1942. Germany's rural electrification rate remained below 30%. This meant American agricultural production was mechanized while German farms still depended heavily on animal and human power. The cumulative effect was that American industrial workers produced food as a side activity, while German farmers absorbed labor that could have been used in factories. By mid-1943, German intelligence services were receiving reports about American production that seemed too absurd to credit. A single Ford factory producing more vehicles monthly than Germany's entire automotive industry. Shipyards launching multiple vessels daily. Aircraft factories with assembly lines over a kilometer long. These reports were filed away as obvious propaganda or intelligence failures. No industrial system could achieve such output. The numbers violated every principle of manufacturing German engineers understood. Then came the captures. As American forces engaged German units in North Africa, Sicily, and eventually Italy, German prisoners of war began entering the American system. Among them were engineers, factory managers, and technical specialists, whose testimony would prove more devastating than any intelligence report. They had seen German industry at its peak. Now they would witness American production at full mobilization. The cognitive destruction of their professional assumptions would be absolute. Klaus Hartmann's journey from German engineering confidence to stunned comprehension began on May 7, 1943, outside Bizerte, Tunisia. His unit, a technical support battalion attached to the 5th Panzer Army, surrendered along with 250,000 German and Italian troops as the North African campaign collapsed. At 40 years old, Hartmann was older than most prisoners, his engineering expertise making him valuable enough to avoid frontline combat service. He had spent the African campaign maintaining tank transmissions and managing repair facilities. Now he was a prisoner, facing an uncertain future. The initial processing at temporary camps in Algeria revealed the first hints of American industrial capacity. The quantity of supplies was staggering. Food arrived in trucks that themselves represented production achievements, standardized vehicles manufactured by the tens of thousands. Medical supplies included drugs German forces hadn't seen in months. The administrative efficiency impressed him despite himself. Thousands of prisoners processed daily with paperwork, photographs, and medical screening completed with mechanical precision. In late June 1943, Hartmann boarded a Liberty ship for transport to the United States. The vessel itself was a lesson in American manufacturing philosophy. He learned from English-speaking guards that the ship had been built in 42 days using prefabricated sections welded together at the Kaiser shipyard in Richmond, California. The concept stunned him. In Germany, ships were built over many months, each one custom-crafted by shipwrights whose skills had been passed down through generations. The Americans had turned shipbuilding into assembly line work. The 2-week Atlantic crossing provided time for reflection and observation. The ship's crew disposed of more food daily than his unit had received weekly in Tunisia. American sailors operated radar systems, automatic weapons, and communication equipment with a casual competence that spoke to extensive training and reliable equipment. Everything about the ship suggested industrial capacity operating at a scale Germany couldn't match. July 15, 1943, Norfolk Naval Base, Virginia. The first sight of American industrial infrastructure demolished Hartmann's remaining assumptions about comparable production capacity. The port stretched for kilometers, its docks handling dozens of ships simultaneously. Cranes lifted cargo with electrical power, moving in minutes what would have required hours of manual labor in German ports. The scale of operations was incomprehensible. In a single hour, Hartmann watched more cargo move than Hamburg's port handled in a day. The trains that would carry prisoners inland provided the next revelation. Not freight cars, but passenger coaches with padded seats, dining cars with white tablecloths. The Germans travelled like tourists while their nation was being bombed into rubble. The psychological impact was calculated, though Hartmann didn't realize it yet. American authorities had learned that demonstrating overwhelming material superiority was more effective than any propaganda in breaking down Nazi ideology. The 3-day train journey from Norfolk to the prison camp in Kansas provided a rolling seminar in American industrial geography. Hartmann pressed his face against windows, documenting everything in a notebook guards allowed him to keep. Through Virginia and North Carolina, he saw textile mills operating around the clock, their windows blazing with light despite wartime conditions. Through Tennessee, the Alcoa aluminum plant stretched along the river for 5 kilometers, its electric furnaces consuming more power than the entire city of Munich. In Kentucky, tobacco warehouses the size of German factory complexes stored agricultural surplus that could have fed armies. The casual abundance was more devastating than any military defeat. Through southern Illinois, the train slowed near an industrial complex that would fundamentally alter Hartmann's understanding of manufacturing. A guard, noting his obvious engineering interest, explained they were passing the Chrysler tank arsenal in nearby Detroit, visible from the rail line. Hartmann stared at the facility, trying to comprehend what he was seeing. The main building covered over 1 million square feet under a single roof. Parking lots surrounded the factory, filled with thousands of workers' private automobiles. The scale was beyond anything in German industry. The guard, a talkative sergeant from Michigan, provided details that sounded like propaganda but proved devastatingly true. The facility had been built in 9 months. It produced Sherman tanks using automobile assembly line methods. At peak production, one tank rolled off the line every 55 minutes. Hartmann did the mathematics in his head. If accurate, this single facility produced more tanks monthly than Germany's entire industry. The guard noticed his expression and smiled. "Wait till you see what else we're building," he said. The train continued west into the agricultural heartland. Through Iowa and Nebraska, Hartmann witnessed farming on an industrial scale that defied comprehension. Single farms covered more land than entire German villages. Mechanical combines harvested grain across horizons that seemed infinite. The surplus production was so vast that some crops were being ploughed under to maintain prices, a concept that caused near psychological breakdown in prisoners from hunger-ravaged Europe. Camp Concordia, Kansas, built specifically to house German prisoners of war, occupied over 400 acres of former farmland. The facility had been constructed in 90 days, another example of American construction speed that seemed impossible by German standards. Barracks with electric lights, flush toilets, hot showers, and steam heat housed 3,000 prisoners, in conditions exceeding what most had known as civilians in Germany. The camp's machine shop, where prisoners would work on contract manufacturing for local industries, provided Hartmann's first direct contact with American production methods. The shop contained machine tools that made German equipment seem medieval, automated lathes that could run for hours without adjustment, milling machines with precision measurements calibrated to thousandths of an inch, electric welding equipment that German factories would have considered experimental. The camp's American shop supervisor, a retired machinist from Wichita named Howard Jenkins, took immediate interest in Hartmann's engineering background. Jenkins had spent 40 years in American manufacturing, from automotive plants to aircraft factories. He became Hartmann's informal tutor in American production philosophy, explaining principles that contradicted everything German engineering education had taught. Their first real conversation occurred in August 1943 as Hartmann operated a turret lathe, manufacturing simple parts for a local agricultural equipment company. Jenkins watched his technique, noting his meticulous attention to achieving perfect tolerances through constant measurement and adjustment. After an hour, Jenkins stopped him. "You're working too hard," Jenkins said in the blunt manner Hartmann would learn to appreciate. "You're trying to achieve precision through skill. That's the old way. We achieve precision through tooling, so skill becomes unnecessary." Hartmann didn't understand immediately. Jenkins took him to a wall where technical drawings hung, specifications for the parts they were manufacturing. "Look at these tolerances," Jenkins said, pointing to dimension. Specifications. 0.005-inch variance allowable. In the old days, craftsmen achieved this through skill and experience. Now we set up the machine tool to these exact specifications. The machine maintains tolerance automatically. The operator just feeds material and monitors output. The implication was staggering. If machines maintained precision automatically, then manufacturing didn't require master craftsmen. Anyone who could follow procedures could produce precision parts. "But the setup must be perfect," Hartmann objected. "The initial calibration requires master-level skill." Jenkins smiled. "That's where American manufacturing philosophy differs from European. We invest enormous resources in the setup, the tooling, the jigs, and fixtures that make production foolproof. One engineer spends a week designing fixtures, then 1,000 workers produce perfect parts without thinking. We separate thinking from doing." This separation was philosophically alien to German industrial culture, where the craftsman's knowledge and execution were unified. A German master machinist took pride in achieving precision through skill, experience, and judgment. The American system eliminated that pride by eliminating the need for it. "Doesn't this produce inferior workers?" Hartmann asked. "Men who don't understand what they're making?" Jenkins considered this seriously. "Maybe," he admitted, "but it produces superior output. I can train a new worker in 2 days to produce parts that would take a German craftsman 2 years to master. When that worker gets drafted, I can replace him in 2 days. Your system depends on irreplaceable craftsmen. Ours depends on replaceable workers following an irreplaceable system. The distinction would haunt Hartmann for the rest of his life. Germany had built an industrial system dependent on scarce, highly skilled workers. America had built a system where the intelligence lived in engineering and tooling, allowing relatively unskilled workers to produce complex products. As Germany lost skilled workers to military service and casualties, production declined. America could absorb unlimited worker turnover without production losses because the system didn't depend on individual skill. Over the following months, Jenkins provided Hartmann with an education in American industrial philosophy that no German university offered. They discussed production planning, where American factories scheduled every operation minute by minute, eliminating downtime that German shops accepted as inevitable. They examined quality control methods, where American statistical sampling replaced German individual inspection, processing thousands of parts in the time German methods required for hundreds. They analyzed supply chain logistics, where American factories received components from hundreds of subcontractors in perfectly timed deliveries, while German factories manufactured most components in-house due to distrust of supplier quality. Most fascinating to Hartmann was the American approach to standardization. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Jenkins explained how American industry had adopted standard measurements, standard threads for bolts, standard sizes for everything from nuts to lumber. This standardization meant that parts from any manufacturer could fit any product. A bolt manufactured in California would thread perfectly into a nut made in Connecticut. This interchangeability was so fundamental that Americans took it for granted, never realizing how revolutionary it was. In Germany, each manufacturer used slightly different standards. A Daimler bolt wouldn't fit a Krupp nut. Every factory maintained its own specifications, requiring custom parts and eliminating interchangeability. This made field repairs difficult and supply logistics nightmarish. American military equipment used standardized parts across manufacturers, allowing any vehicle to be repaired with parts from any supply depot. The efficiency advantage was incalculable. By December 1943, Hartmann was working on increasingly complex projects in the Camp machine shop. The contracts came from American companies desperate for manufacturing capacity as their workers entered military service. Prisoners of war, forbidden by Geneva Convention from direct war production, could work on civilian projects that freed American labor for military work. This technicality allowed Hartmann to witness American industrial capacity from inside the system. One contract came from a small aircraft parts manufacturer in Wichita. The company needed thousands of aluminum fittings for B-29 bomber hydraulic systems, simple parts, but requiring precise tolerances. Hartmann was assigned to design the production setup. Using principles Jenkins had taught him, he designed fixtures and jigs that allowed prisoners with minimal training to produce parts to exact specifications. The setup took 2 weeks. Once operational, workers produced perfect parts without requiring skill or judgment. The production rate exceeded the American company's expectations by 40%. The company's purchasing agent visited the camp to thank the prisoners personally, a gesture that bewildered Germans accustomed to being treated as expendable cogs. He explained that the parts they produced would help build bombers that would bomb Germany. The irony was not lost on Hartmann, who was participating in his own nation's defeat through superior production methods. But professional fascination exceeded patriotic qualms. He was learning secrets of American industrial success that no amount of intelligence gathering could have revealed. Spring 1944 brought an opportunity that would complete Hartmann's education. The U.S. Army's Technical Intelligence Division identified several German prisoners with engineering backgrounds for a special program. These prisoners would visit American factories to document production methods for post-war reconstruction planning. The program's stated purpose was preparing German engineers to rebuild their nation's industry after the war using modern methods. The unstated purpose was psychological. Let them see American production at full war mobilization and understand that resistance was futile. Hartmann was selected among 50 German engineer prisoners for this program. In May 1944, he began a 2-month tour of American industrial facilities that would demolish every remaining assumption about comparable German capability. The tour began at the Willow Run bomber plant outside Detroit. Nothing could have prepared Hartmann for what he witnessed. The facility stretched over 1 kilometer, its roof covering 2.5 million square feet. Inside, 7,500 workers assembled B-24 Liberator bombers on a moving production line that operated continuously. Hartmann watched, stunned, as aircraft moved through assembly stations like automobiles. Wings manufactured in one section, fuselages in another, all converging on the main assembly line where final integration occurred with mechanical precision. His guide, an Army technical officer named Captain Robert Morrison, provided statistics that sounded impossible. At peak production, one complete bomber rolled out every 63 minutes. Each aircraft required 1.5 million parts from over 1,500 subcontractors across 40 states. The coordination required to synchronize this supply chain exceeded anything German industry had attempted. "How do you manage the suppliers?" Hartmann asked in his careful English. Morrison explained the system patiently. Each supplier manufactures to specifications so precise that no adjustment is needed. Parts arrive here and bolt directly into position. We don't hand-fit anything. If a part doesn't fit perfectly, we reject it and the supplier fixes their process. Hartmann did rapid calculations, but with 1,500 suppliers, the rejection rate must create chaos. Morrison shook his head. Less than a 5% rejection rate. Our suppliers know that maintaining specifications is cheaper than fixing rejects. American industry learned that quality at the source costs less than inspection and correction. This was the revelation that would haunt Hartmann most profoundly. German industry invested enormous resources in inspection and correction, accepting that craftsman-built products would vary and require adjustment. American industry invested in front-end engineering that eliminated variation at the source, making inspection nearly unnecessary. The cost savings and production acceleration were both enormous. At a sub-assembly station, Hartmann watched workers install 4 engine assemblies into wing sections. The operation took 17 minutes per bomber. He knew from his technical reading that German aircraft factories required 2 days for similar work. "Your workers are remarkably skilled," he said to Morrison. Morrison laughed. Most of these workers had never seen an airplane before starting here. The average training time is 4 days. The system makes them productive, not their skill. He pointed to a young woman, perhaps 20 years old, operating a riveting machine. "She's installing pressure bulkhead rivets. In a German factory, this would require a master aircraft mechanic with years of experience. She learned it in 6 hours because the fixtures position everything perfectly. She just pulls the trigger." The democratization of complex manufacturing through systematic engineering was the invisible revolution that German industry had missed. At the Ford Rouge complex, Hartmann witnessed vertical integration that exceeded anything in German industry. Raw materials entered one end. Finished products, in this case jeeps and aircraft engines, exited the other. The facility employed 90,000 workers, consumed enough electricity to power a city of 500,000, and operated its own steel mill, glass factory, and power generation station. The scale was so immense that comprehension required hours of observation. Hartmann stood on a viewing platform overlooking the main assembly floor, watching assembly lines stretch into the distance until they became mere suggestions of motion in the haze. Vehicle assembly occurred every 2 minutes, engine assembly every 60 seconds. The speed was hypnotic and horrifying. Morrison provided context that made the horror complete. This is one of 7 major Ford facilities. General Motors operates 12 similar plants. Chrysler has 6. This is just automotive production converted to military use. Our actual military facilities are even larger. The implications crushed Hartmann's remaining hope for German victory. If America had dozens of facilities this size, if each one could be rapidly converted to military production, if this capacity operated in addition to dedicated military plants, then Germany's industrial base was laughably inadequate by comparison. The June 1944 trip to Kaiser's shipyards in Richmond, California proved even more devastating. Hartmann watched Liberty ships under construction in parallel ways, each vessel proceeding through identical stages simultaneously. The modular construction method was revolutionary. Complete ship sections, prefabricated and fully equipped, were lifted by massive cranes and welded into position. A ship that would have required 6 to 12 months in traditional construction was completed in 42 days on average. Kaiser's record-setting vessel, the SS Robert E. Peary, had been built in 4 days, 15 hours, 29 minutes, a feat that would have been dismissed as impossible propaganda if Hartmann hadn't been shown documentation and photographs of the actual construction. The yard superintendent, a gruff veteran of maritime construction named Carl Peterson, explained the philosophy as they toured the facility. Traditional shipbuilding treated each vessel as a custom product. Master shipwrights crafted each one individually. We treat ships as manufactured products assembled from standardized modules. The modules are built in parallel by workers who don't need traditional skills. They just follow procedures. This industrialization of traditionally artisanal work was America's secret weapon. Where German industry clung to craft traditions that limited production speed, American industry ruthlessly eliminated craft in favor of systematic engineering. At a module fabrication building, Hartmann watched workers, many of them women, welding ship hull sections. Electric welding had replaced riveting, reducing both time and weight while creating stronger joints. The welders wore protective gear and worked continuously, their torches creating a continuous lightning storm of industrial power. Peterson noted Hartmann's interest. Welding was experimental before the war. We've trained 40,000 welders in 3 years. Most had never held a torch before. 2 weeks of training and they're producing work that meets specifications. The casual mention of 40,000 trained welders revealed the scale of American industrial education. Germany couldn't have trained 40,000 welders in a decade under its apprenticeship system. America had done it in 3 years by breaking down complex skills into teachable procedures. Back in Detroit, Hartmann toured the Chrysler Tank Arsenal, the facility he had glimpsed from the train a year earlier. Walking through it physically was different from seeing it at a distance. The scale was crushing. The main building covered 1.25 million square feet. The assembly line ran nearly a quarter mile through the center of the facility. Tanks moved along this line on specialized carriers, stopping at each station for precisely timed operations. The production speed was shocking. Hartmann watched as turrets were mated to hulls, engines installed, weapons mounted, in a continuous flow that delivered one complete M4 Sherman tank every 55 minutes. The facility manager, a Chrysler executive named James Crawford, provided a tour that combined technical detail with strategic implications. We designed this facility from scratch for tank production. Albert Kahn, our architect, created a building optimized for linear flow. Raw materials enter the west end, finished tanks exit the east. Everything in between is synchronized to that rhythm. Hartmann examined the production line stations carefully. Each operation must be timed precisely to maintain flow. Crawford nodded. We've analyzed every operation, broken it into minimum time components. Workers specialize in specific tasks, repeated hundreds of times. The expertise lives in the procedure and fixtures, not the individual worker. At a station where workers installed suspension systems, Hartmann watched the operation. This would take German mechanics 6 hours, he said quietly. Crawford checked his clipboard. We allocate 23 minutes. The suspension comes as a pre-assembled module, tested before installation. Workers bolt it into position using pneumatic tools and pre-positioned fixtures. No adjustment, no fitting, no thinking required. The elimination of thinking from production work was the transformation German engineering culture couldn't accept. German craftsmen took pride in solving problems during assembly, adapting to variations, using judgment honed over years. American workers followed procedures that eliminated variation and thereby eliminated the need for judgment. One system honored skilled workers, the other rendered them unnecessary. Crawford took Hartmann to the quality control station, where finished tanks underwent final inspection. We check dimensional accuracy. Systems, operation, weapons function. Rejection rate is below 2%. Rejected vehicles go to a remediation line where specific problems are fixed in an average 40 minutes. In German factories, Hartmann knew, every tank required adjustment and correction before acceptance. The difference wasn't that American tanks were built better, it was that American tanks were engineered so precisely that building them required no skill. The tour concluded with statistics that Crawford delivered without dramatic emphasis, understanding that the numbers spoke for themselves. This facility has produced 22,000 tanks since April 1941. Current production averages 750 units monthly. We employ 11,000 workers operating 3 shifts. By comparison, German tank production from all facilities averages 350 monthly, based on our intelligence estimates. Hartmann's mental mathematics confirmed German defeat. This single American facility outproduced Germany's entire tank industry 2-1. If America operated multiple such facilities, if they could expand production further, if this capacity existed in addition to aircraft, ship, and artillery production, then Germany was fighting industrial mathematics that couldn't be overcome through courage or tactical brilliance. Throughout the summer of 1944, Hartmann visited aircraft engine factories, artillery plants, electronics manufacturers, and chemical facilities. Each one demonstrated the same principles. Systematic engineering eliminated craft skill requirements. Precision tooling enabled unskilled workers to produce complex products. Standardization created interchangeability. Vertical integration and supplier coordination enabled vast production networks to operate with mechanical precision. But the philosophical implications went deeper than specific techniques. American industry had made a fundamental choice that German industry rejected, treating workers as replaceable components in an engineered system rather than as skilled craftsmen whose expertise was essential. This choice seemed degrading to human dignity by German cultural standards, but it was devastatingly effective in wartime production. An American factory could lose half its workforce to military service and maintain production by training replacements in weeks. A German factory losing half its craftsmen would see production collapse because the expertise was irreplaceable. By August 1944, Hartmann was writing detailed reports about American production methods for the U.S. Army Technical Intelligence Division. These reports would eventually contribute to post-war German reconstruction, but in 1944, they served mainly to document the magnitude of German industrial failure. In one report, Hartmann tried to explain why American methods couldn't have been implemented in Germany even if the principles had been understood. The Craftsman Guild system controlled production standards and would have rejected any method that eliminated craft skills. German electrical infrastructure couldn't have powered the automated systems American factories depended on. German capital markets couldn't have financed the enormous upfront investment in tooling and engineering that American methods required. German culture couldn't have accepted the radical separation of thinking from doing that American production lines embodied. The conclusion was devastating. Germany hadn't just lost a production competition, Germany had built an entire industrial culture incompatible with modern mass production warfare. The realization that German defeat was inevitable due to industrial philosophy rather than military mistakes was crushing to a patriotic engineer. But Hartmann was a scientist at heart. Understanding the truth mattered more than comforting illusions. September 1944 brought news of the Allied advance across France. Paris was liberated, German armies retreating, the Western Front collapsed. In the camp at Concordia, Kansas, German prisoners gathered around radios, listening to BBC broadcasts describing their homeland's demolition by American-produced bombers. The irony was bitter. Hartmann knew that the B-17 and B-24 bombers destroying German cities were produced at rates German aircraft industry couldn't match by 5-1. The bombs falling on Hamburg and Berlin were manufactured in quantities that German industry couldn't approach. Even the fuel in American bombers' tanks came from refineries producing petroleum products at scales Germany never achieved. Total war had become an industrial competition, and Germany's craftsman-based production couldn't compete against America's systematically engineered mass production. The December 1944 meeting changed Hartmann's understanding of his role. Major William Horace from the Army's Civil Affairs Division visited Camp Concordia specifically to meet with engineer prisoners selected for the reconstruction program. Horace explained that Germany would need to rebuild its industrial base after the war using modern methods. Engineer prisoners with understanding of American production techniques would be essential to this reconstruction. "You'll return to Germany eventually," Horace said to the assembled group. "When you do, you'll have knowledge that most Germans don't possess. You've seen American industrial methods firsthand. You understand why they work. Your knowledge will be valuable in rebuilding a peaceful, prosperous Germany." The concept of being valuable in defeat was psychologically complex. Hartmann and his fellow engineer prisoners had fought for Germany. Now they were being prepared to rebuild Germany using the methods of their conquerors. The cognitive dissonance was profound, yet Hartmann recognized the logic. Germany's industrial philosophy had failed catastrophically. Continuing those methods would condemn post-war Germany to permanent inferiority. Learning from American success was Germany's only path to recovery. January 1945 brought the final phase of Hartmann's education. He was transferred to a special facility at Fort Getty, Rhode Island, where engineer prisoners attended intensive courses taught by American industrial experts. The program, codenamed Operation Paperclip's civilian counterpart, aimed to create a cadre of German engineers who understood modern production methods and could lead post-war reconstruction. The curriculum was comprehensive. Production engineering, taught by professors from MIT and Carnegie Tech. Statistical quality control, presented by experts from Bell Labs. Supply chain logistics, explained by executives from Sears Roebuck, whose retail distribution network was being studied as a model for industrial coordination. Industrial electrification, demonstrated through case studies of rural electrification and factory power systems. The instructors treated German prisoners not as enemies but as students. Professional respect transcended wartime animosity. American engineers recognized that German technical education was excellent. What Germans lacked was not capability but philosophy. Teaching them American industrial methods would benefit post-war reconstruction and potentially create democratic allies through economic integration. One lecture in February 1945, delivered by Dr. Harold Whitmore from the Harvard Business School, articulated the philosophical transformation that American industry represented. Hartmann took notes frantically, recognizing that he was hearing the conceptual foundation of everything he had witnessed. European industry, including Germany, developed from craftsman guilds, Whitmore began. This created an industrial culture that valued individual skill, custom production, and perfect quality in each unit. These are admirable values but incompatible with modern mass production. American industry developed differently. We had labor shortages from the beginning. We needed systems that allowed unskilled workers to produce quality goods. This necessity drove us to invest heavily in front-end engineering. We design products for manufacturability. We create tooling that makes precision automatic. We standardize everything to enable interchangeability. We separate design from production, allowing engineers to focus on system optimization while workers focus on execution. Whitmore continued with economic analysis that Hartmann found revelatory. The craftsman system invests in human capital, skilled workers developed over years. The American system invests in physical capital, tooling and equipment that encode expertise. Human capital is irreplaceable and slow to develop. Physical capital can be rapidly expanded through industrial production. In wartime, when you need to expand production tenfold in 2 years, the American system scales. The craftsman system doesn't. This explained why American war production had increased so dramatically while German production stagnated. America could build new factories, install machinery, and train workers in months. Germany needed years to develop new skilled craftsmen, and couldn't expand production beyond craftsman availability. Another instructor, James Patterson from General Electric, provided a lecture on standardization that resonated deeply with Hartmann's observations. Before standardization, every manufacturer used proprietary specifications. This created artificial complexity. A light bulb from one manufacturer wouldn't fit another's socket. A bolt from one factory wouldn't fit another's nut. Standardization eliminated this waste. Now any light bulb fits any socket, any standard bolt fits any standard nut. The efficiency gains are incalculable. Manufacturers compete on quality and price, not on proprietary specifications. Consumers benefit from interchangeability. The entire economy operates more efficiently. Patterson showed photographs of American military equipment being repaired in field conditions using parts from any supply depot. Then he showed photographs of German equipment requiring manufacturer-specific parts, creating supply nightmares. "Your military fought with one hand tied behind its back," Patterson said bluntly. "Logistics problems your military faced were self-inflicted through failure to standardize. You built excellent equipment to incompatible specifications." The criticism stung because it was accurate. Hartmann remembered constant supply problems in North Africa. Tank repairs delayed because parts from the wrong manufacturer didn't fit. Artillery pieces sitting idle because ammunition from different producers varied slightly. The Wehrmacht's logistics were nightmarish, partly due to industrial philosophy that resisted standardization. March 1945 brought news of American forces crossing the Rhine. The war's end was approaching rapidly. In the Fort Getty classroom, German engineer prisoners studied American production methods with increasing urgency, understanding that this knowledge would soon be needed for reconstruction. Dr. Whitmore delivered a lecture on post-war planning that outlined America's vision for German industrial reconstruction. The Marshall Plan, not yet formally announced, will provide financial assistance for European reconstruction. But money alone won't rebuild Germany. You need modern industrial methods. You'll need to abandon craft-based production in favor of systematic engineering. You'll need to electrify completely. You'll need to adopt standardization. You'll need to accept that workers are components in an engineered system, not craftsmen performing individualized work. The prospect of transforming German industrial culture seemed overwhelming. Hartmann raised his hand. This requires changing not just methods, but values. German culture honors craftsmanship. The master craftsman has social status similar to a doctor or lawyer. Reducing workers to interchangeable components seems degrading to human dignity. Whitmore nodded, acknowledging the concern. This is the hardest part. You're not wrong that American methods treat workers as replaceable components. But consider the alternative. Germany's craftsman system created a rigid class structure. Only those who could afford years of apprenticeship became master craftsmen. Everyone else remained unskilled labor. American methods democratize production. Any worker can quickly learn to produce complex goods. This creates social mobility and middle-class prosperity. Your craftsman system preserved aristocratic distinctions. Our system creates opportunity. The argument was persuasive but troubling. Hartmann recognized that American industrial democracy and social mobility went hand in hand. The same system that made workers replaceable also made them prosperous by enabling mass production that lowered prices while raising wages. April 19, 1945. News reached Fort Getty that Soviet forces had entered Berlin. The Reich was in its final throes. The engineer prisoners in the reconstruction program listened to radio broadcasts describing their homeland's destruction with numb acceptance. Everything they had fought for was collapsing. Everything they had believed was revealed as delusion. The industrial methods they were studying represented not just technical knowledge, but philosophical surrender to American values. Yet Hartmann felt something unexpected. Hope. Germany would survive. The nation would need rebuilding. Engineers with knowledge of modern production methods would be essential to creating a peaceful, prosperous post-war Germany. His captivity had transformed from punishment to preparation. May 8, 1945, Victory in Europe Day. The war was over. In the Fort Getty auditorium, Major Horace addressed the assembled German engineer prisoners with a speech that outlined their future role. "You'll be repatriated gradually over the next year. When you return to Germany, you'll find a devastated nation that needs rebuilding. You have knowledge that will be invaluable in that reconstruction. You've seen American industrial methods. You understand why they work. You've received training in modern production techniques. Your mission is to help build a new Germany, democratic and prosperous, integrated into the Western economic system." The transformation was complete. They had entered American captivity as enemies. They would leave as ambassadors of American industrial philosophy, prepared to rebuild Germany using the methods of their conquerors. The summer of 1945 brought a curious interlude. With the war over but repatriation not yet organized, engineer prisoners at Fort Getty were employed as consultants to American companies studying post-war European reconstruction. Hartmann found himself advising a machine tool manufacturer on German market conditions, explaining what equipment German factories would need, what technical specifications European standards required, how to adapt American products for European use. The irony was complete. A German engineer, recently an enemy combatant, was helping American companies plan their economic penetration of post-war Germany. Yet this collaboration made sense. American industry needed information about European markets. German engineers needed employment and income to support families in devastated Germany. Economic integration served both parties' interests. One consulting project particularly fascinated Hartmann. A consortium of American automotive manufacturers wanted to understand whether the German automotive industry could be revived using American production methods. Hartmann spent weeks preparing a detailed analysis. His conclusion was optimistic but conditional. The German automotive industry had excellent engineering tradition but outdated production methods. With American capital for retooling, with technical assistance to implement assembly line production, with training in modern quality control, the German automotive industry could become competitive. The prerequisite was abandoning craftsman-based production in favor of American systematic engineering. The report Hartmann prepared would later be credited with influencing American decisions to support German automotive industry reconstruction. Volkswagen, BMW, and Mercedes would eventually adopt American production methods while maintaining German engineering excellence, creating a hybrid system combining both traditions' strengths. September 1945 brought Hartmann's final interview before repatriation. Major Horace asked him to reflect on his time in American captivity and what he had learned. Hartmann's response, recorded in declassified archives, provides insight into the psychological transformation that thousands of German engineer prisoners experienced. "I arrived believing German engineering was superior to American. I was wrong. German engineering tradition is excellent for custom products and precision equipment, but modern mass production requires a different philosophy. The American industry doesn't try to build perfect products. It tries to build good enough products in quantities so vast that statistical advantage overwhelms individual quality. A German tank might be superior to an American tank in one-on-one combat, but when America produces 5 tanks for every German tank, individual superiority becomes irrelevant. This is the lesson German industry never learned. We optimized individual products when we should have optimized production systems." Horace pressed him on cultural implications. Can Germany adopt American methods without becoming America? Hartmann considered carefully. Germany must adapt, not adopt. We can learn American production methods while maintaining German engineering excellence. We can standardize components while customizing final products. We can use systematic engineering for high-volume production while preserving craftsman traditions for specialized work. The future is hybrid, combining American efficiency with German quality. This synthesis would characterize post-war German industrial reconstruction, creating the economic miracle that transformed West Germany into Europe's industrial powerhouse within 15 years. October 1945. Hartmann boarded a transport ship for repatriation to Germany. He carried with him a footlocker containing technical manuals, production textbooks, and detailed notes from 2 years of studying American industrial methods. The American authorities encouraged this, understanding that German reconstruction required knowledge transfer. The Atlantic crossing provided time for reflection. Hartmann wrote in a journal that his family would preserve for decades. I left Germany in 1943 believing in German superiority. I returned knowing that belief was a delusion. America's industrial capacity is not just larger than Germany's, it is conceptually different, built on philosophical foundations that German culture rejected. The craftsman tradition we honored created production constraints that modern warfare couldn't tolerate. America's systematic engineering, which seemed degrading to human dignity, actually democratized prosperity by making complex products affordable to ordinary people. This is the paradox I must explain to fellow Germans. We lost the war because our industrial values were wrong. Rebuilding Germany requires adopting our conquerors' methods. This is not surrender, but wisdom. The ship docked at Bremerhaven in November 1945. Hartmann stepped onto German soil for the first time in 2.5 years. The devastation was shocking, even though he had been prepared by photographs and descriptions. Cities reduced to rubble, factories destroyed, infrastructure collapsed, millions homeless. Yet amid the destruction, Hartmann saw opportunity. Germany would have to rebuild from scratch. This catastrophe created the possibility of building correctly using modern methods rather than reconstructing obsolete systems. The blank slate that total defeat had created might enable the transformation that peacetime inertia would have prevented. Thank you for reading. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe. Hartmann's post-war career embodied the transformation of German industry. He joined the Reconstruction Administration in the American occupation zone, advising on industrial policy. His knowledge of American production methods made him invaluable in planning factory reconstruction. He consulted for German companies retooling with Marshall Plan funds, teaching American assembly line techniques adapted for European conditions. He taught at technical universities, training a new generation of German engineers in systematic production engineering. By 1950, Hartmann was technical director at a rebuilt ball-bearing factory in Stuttgart, the successor to the Schweinfurt facility that had been destroyed by Allied bombing. The new factory embodied everything he had learned in America. Electric-powered automated production lines where the original had used belt-driven machinery, precision tooling that eliminated hand-fitting where the original had relied on craftsman skill, statistical quality control where the original had used individual inspection, standardized components interchangeable across product lines where the original had custom manufactured each bearing. Production capacity exceeded the old Schweinfurt factory by 300%, with 30% fewer workers. The transformation was complete. The 1950s brought Germany's economic miracle, the Wirtschaftswunder that rebuilt the nation into Europe's industrial leader within one generation. Multiple factors contributed, but one was the knowledge that returning prisoners of war brought home. Over 370,000 German soldiers had been held in American camps. Among them were thousands of engineers, factory managers, and technical specialists who had witnessed American industrial methods firsthand. These men became evangelists for modern production, spreading American techniques throughout German industry. The hybrid system that emerged combined German engineering tradition with American production efficiency. German companies maintained a reputation for quality while achieving American-style production volumes. Mercedes-Benz built luxury automobiles on assembly lines. BMW produced precision motorcycles with interchangeable parts. Siemens manufactured electrical equipment using systematic engineering that would have impressed Henry Ford. By 1960, West Germany had become the world's second-largest exporter after the United States. The German engineering that became internationally synonymous with quality was actually German design married to American production methods. The synthesis worked precisely because it combined both traditions' strengths. In 1967, Klaus Hartmann retired from active engineering at age 64. He had spent his career rebuilding German industry using principles learned in American captivity. His final major project was consulting on the Volkswagen factory expansion that would make the Beetle the best-selling automobile in history. The Beetle's success rested on American mass production methods applied to German engineering, producing an affordable, reliable car that democratized automobile ownership in post-war Europe. Hartmann spent his retirement writing a technical memoir documenting German industrial transformation. The book, published in 1971 as From Craftsman to System, Industrial Lessons from American Captivity, became required reading in German engineering schools. In it, Hartmann articulated the philosophical transformation that his generation had experienced. We left Germany as believers in craftsman tradition, convinced that individual skill and perfect quality were the highest industrial values. We returned understanding that systematic engineering and mass production were not inferior alternatives, but superior methods for different purposes. The craftsman tradition remains valuable for custom work, artistic production, and specialized equipment. But modern industrial society requires mass-produced goods, affordable to ordinary people. American methods made this possible by treating manufacturing as an engineering problem, to be solved systematically, rather than a craft skill to be developed individually. This was the revolution that German industry had missed while clinging to guild traditions that served us well in the 19th century, but failed catastrophically in the 20th. The post-war German miracle was not a miracle at all. It was the predictable result of applying proven methods. We rebuilt German industry using American principles: standardization for interchangeability, precision tooling to eliminate hand-fitting, statistical quality control to replace individual inspection, assembly line production to maximize output, electrification to enable automation. These methods succeeded not because Americans were superior people, but because American philosophy was correct. Modern mass production requires systematic engineering, not craftsman skill. This lesson, learned in defeat, became the foundation for German prosperity. Hartmann died in 1983, at age 80, having witnessed Germany's transformation from defeated ruins to industrial powerhouse. His funeral in Stuttgart was attended by hundreds of engineers, industrialists, and former students. The eulogy, delivered by a colleague from the post-war Reconstruction Administration, captured his historical significance. Klaus Hartmann was among thousands of German engineers who were captured in war, educated in captivity, and returned to rebuild their homeland using their enemies' methods. This willingness to learn from defeat, to abandon failed traditions in favor of proven alternatives, to synthesize German engineering excellence with American production efficiency, created the post-war German miracle. Hartmann never forgot that his education in American industrial methods came during captivity as a prisoner of war who had fought against the nation that would later teach him. This paradox shaped his worldview. He understood that strength came not from rigidity but from willingness to learn. That defeat could become opportunity if lessons were absorbed rather than rejected. That cultural traditions should be preserved where valuable and discarded where obsolete. His generation rebuilt Germany not by restoring what had been destroyed but by creating something new, a hybrid industrial culture combining German engineering discipline with American production efficiency. This synthesis made Germany prosperous and peaceful, integrated into Western economic systems, committed to democratic values. These achievements justify the painful lessons that made them possible. The historical significance of the German engineer-prisoner experience extends beyond individual stories to illuminate broader questions about technological transfer, cultural transformation, and post-war reconstruction. The program succeeded because it relied on demonstration rather than instruction. German engineers weren't told that American methods were superior. They witnessed superiority directly. They saw production volumes that German industry couldn't match. They operated machine tools more advanced than German equipment. They studied factories whose efficiency exceeded anything in German experience. This evidence was irrefutable. The psychological impact was carefully calculated by American authorities who understood that breaking down Nazi ideology required more than military defeat. Material evidence of American superiority demolished propaganda claims about decadent, weak democracy more effectively than any counter-propaganda could have achieved. German engineers trained in the tradition of technical objectivity couldn't dismiss what they directly observed. The numbers were undeniable. The methods were documentable. The results were measurable. The program's success influenced American occupation policy throughout Europe and later in Japan. The principle was consistent. Convert former enemies into future allies by demonstrating democratic capitalism's material superiority. Teach modern industrial methods to rebuild destroyed economies. Integrate former enemy nations into Western economic systems through trade relationships, requiring modern production methods. Create middle-class prosperity that would support democratic politics. This strategy succeeded beyond expectations. West Germany, rebuilt using American methods and capital, became a staunch NATO ally and economic partner. The engineers who had witnessed American industrial capacity in captivity became leaders of German reconstruction, implementing lessons learned in prison camps to create Europe's strongest economy within 2 decades of total defeat. The contrast with East Germany, rebuilt under Soviet methods, validated the American approach. West German industry, using systematic engineering and modern production methods, achieved productivity and prosperity that East German craftsman-based production under central planning couldn't match. By 1989, when the Berlin Wall fell, West Germany's per capita income was nearly triple East Germany's. This disparity wasn't explained by resources or culture, since both Germanys shared the same pre-war industrial tradition. The difference was industrial philosophy. West Germany had adopted American production methods. East Germany had retained traditional approaches under the Soviet command economy. The economic divergence demonstrated what Klaus Hartmann and his fellow engineer prisoners had learned in American captivity. Industrial philosophy determines economic outcomes as surely as military strategy determines battlefield results. Modern mass production warfare required industrial methods that craftsman traditions couldn't provide. The nations that understood this principle and implemented systematic engineering won both the war and the peace. The story of German engineers stunned by American assembly lines ultimately reveals a truth about technological competition between systems. Superior technology matters less than superior implementation. Germany possessed engineering knowledge equal or superior to American expertise in many fields. What Germany lacked was industrial philosophy that could translate engineering excellence into mass production. American industry excelled at making good enough products in overwhelming quantities. This pragmatic approach, which German craftsmen dismissed as inferior, proved strategically decisive. Quality mattered less than quantity when production volumes differed by factors of 5 or 10 to 1. The lesson resonates beyond World War II history. In any technological competition, the system that can be implemented at scale defeats the system that optimizes individual performance. This principle explains Silicon Valley's dominance in software, China's manufacturing capacity, and countless other contemporary phenomena. Klaus Hartmann and thousands of German engineers like him learned this lesson through direct observation of American industrial capacity at full wartime mobilization. They witnessed what their pre-war ideology had insisted was impossible: democratic, free-market society outproducing authoritarian, centrally planned economies through superior industrial organization. The cognitive demolition of their assumptions was complete and permanent. They returned into Germany as converts, prepared to rebuild their nation using their enemies' methods. In their transformation lay the seeds of post-war German prosperity and the ultimate defeat of totalitarian ideology. They had seen the eighth wonder of the world, the American industrial system at peak production, and they recognized that it was not wonder at all, but the logical result of systematic engineering applied to manufacturing. This recognition, painful as it was to professional pride shaped by different traditions, enabled the transformation that created modern Germany. The engineers who had called American assembly lines the eighth wonder of the world eventually understood a deeper truth. The real wonder was not the machinery, but the philosophy, the American insight that manufacturing should be treated as an engineering problem to be solved systematically, rather than a craft tradition to be preserved reverently. This insight, learned in defeat and applied in reconstruction, transformed German industry and, through it, German society. The wonder was not that America possessed assembly lines, but that America had understood what assembly lines represented. The democratization of production, the transformation of manufacturing from elite craft to systematic engineering, the creation of prosperity through making complex goods accessible to ordinary people. This was the revolution that German engineers witnessed in American captivity and brought home to rebuild their nation. In the end, American industrial might won not just the war but the peace by converting enemies into students, demonstrating superiority that couldn't be denied, and teaching methods that enabled former adversaries to prosper as allies. The German engineers who learned these lessons became architects of European reconstruction and ambassadors of the industrial philosophy that had defeated them. Their story remains testament to the transformative power of undeniable evidence and the human capacity to learn, even from painful defeat.